Hello, biologists. Today we're going to talk about climate change, but first I want you to take a moment to do some self-reflection. I want you to ask yourself, how do I know that something is true? Am I willing to change my mind when I learn new facts? And are there any topics that I flat out refuse to alter my opinions on? Please pause the video, reflect, and I'm asking because our topic today is divisive. Democrats and Republicans are more divided on climate change than on any other issue, including gun violence, racism, and immigration. This data is from Pew Research Center. It's from 2023. And you might be wondering, how did they get this fact? I'll show you. So they did a survey, and in this survey, they asked people, which way do you lean politically? And what kind of things are you worried about? So the title is Partisan Differences in Assessments of Many National Problems, but both Republicans and Democrats see the ability of parties to work together as a problem. That is the one thing that we really see closely on. We can see that as the third item down here. We know that we agree because our two dots are really closely together. The blue dot is Democratic leaning, the red dot is Republican leaning. I assume that we have both Democrats and Republicans in this class, and that is awesome. We want a diversity of opinions in our classes. We don't want to all think the same thing. We don't want to have an echo chamber. We want to have effective discussions. And so we need to have different ideas. In our graph here, in our chart, we have Democrats in blue and Republicans in red. And it's really interesting to me to see when the colors swap. So we have red on the right here, but then we have blue on the right here. Feel free to pause the video at any time and look at these charts more closely because I'm going to go through several of them. This is one long one, so this is the top half. What are we really interested in here, the second half of it? We're interested in this spread. So 14% of Republican-leaning folks say that climate change is a very big problem in our country today. And 64% of Democratic-leaning folks say that climate change is a very big problem. Note that they bolded very big because maybe people wouldn't have said yes or no if it was just big. So it's very big is the category. We're also very well aligned on unemployment, so I think that is interesting too. We have more data from Pew. Pew also asked Republicans and Democrats whether or not they have the same emotional reactions to climate change in the news. So here we have percent who feel blank when thinking about the news and information on climate change they've come across recently. We have Republicans in red and Democrats in blue. Please go ahead and pause the video and read this. It's really interesting. There's some things that we're closer on and some things that we're further about. We also have more data from Pew. This title is Republicans are less likely than Democrats to say that human activity contributes to global climate change. And this is the percent who say that burning fossil fuels is fueling climate change. We have a great deal, some, not too much, not at all. And then we have our breakdown of overall US adults and then categorized by our political affiliation. So fascinating to me. This is a little more recent than the other data. This is from 2024. The other data is from 2023. We also can divide people on age and see what they think about the issues that are facing us, specifically climate change. That's the one that we want to talk about today. And in general, younger adults are less likely than older adults to view most issues as very big problems. And again, we have that qualifier, very big, with the exception of unemployment and climate change. So here we have color differences again, and the different ideas that they asked about. Are these things very big problems? This is one graph split into two, so you can see both sides at once. And our ages 18 through 29 are kind of in a olive green. And then under 50 is our yellow. And then 50 to 64 is purple. And over 65 is darker purple. And it's fascinating to me to see the spreads between our ages, but also areas where the purple swaps to the left and the olive color swaps to the right, which is what we see on qualities of schools, affordability of healthcare, unemployment, and climate change. So these are fascinating topics and things that we obviously care about. So really interesting to discuss. Now let's get a little more local. What do Oregonians think? Here we have their data from 2023. This is not from Pew. This is from Yale Climate Maps. What they do is they survey people in different states, Yale University, and then they ask your opinion about things. So this is Oregon's data. Oregon, 75% of Oregonians think that climate change is happening. Note that Yale used the term global warming. Those are synonyms. So the term global warming, climate change, same thing. We moved away from global warming because it kind of implies that like warming is not the thing that's going to happen. And it's true that warming is part of it, but it's not the only thing that's going to happen, which is why we use climate change now. We also in the 70s briefly called it global cooling. So our vocab adjusts as we learn more. Anytime you see global warming, just think climate change. Some people also use climate crisis. I like the less reactive climate change term. So 75% of Oregonians agree global warming is occurring. Then global warming is caused by mostly human activities. 59% of Oregonians agree. Scientists think global warming is happening. 61% of Oregonians agree. And global warming is affecting the weather. 67% agree. Now we're going to think about risk perceptions. 67% of Oregonians are worried about global warming. 73% say global warming will harm future generations. 71% says it will harm people in developing countries. 65% say it will harm people in the United States. And then that's interesting is all of those things drop down. Global warming will harm me personally. Only 48% say yes to that. So we do think it's a problem. We just don't think it's a problem for us. Now let's think about policy support. 76% of Oregonians agree we should teach global warming in school, which I'm happy to see because here I am teaching about climate change. 80% of us think that we should fund renewable energy sources. 74% think we should have a tax rebate for energy efficient vehicles and solar panels. 75% of us think we should regulate CO2 as a pollutant. And then we're going to talk about the last two items. Oregonians discuss global warmingly, at least occasionally, only 43% of us. Oregonians hear about global warming in the media at least once a week, only 41% said yes to that. So we worry about it, we think we should be doing things about it, but we don't talk about it, we don't think it affects us. Lastly, who should do more about global warming? And the highest number is 71% for corporations. I think that is pretty spot on. Following Congress, then citizens, followed by my local government officials, the president, and my governor. So it's fascinating to see what we think as a people. What is going on with climate change? How is it working? What are the gases involved? Where they come from? Let's get into the science now. So climate change is the reaction to increased greenhouse gases in our atmosphere, which trap heat. If we had the normal greenhouse effect, our solar radiation would come to Earth. It passes through the atmosphere on the way in. That's what this orange line is. Some of it is trapped and it re-radiates and it heats the Earth, but more of it escapes and just goes into space. The greenhouse effect you can feel if you ever get into a car on a hot day. The sunlight goes into a car and it heats the space inside the car hotter than it does outside the car. That's because light goes through the glass, but then it gets trapped inside the car and the car gets pretty hot. With an increase in carbon dioxide, we trap more heat. So carbon dioxide increases the ability of the atmosphere to hold heat. And so more greenhouse gases means more heat. It's this arrow right here. It's thicker, it's bigger, more heat radiates back, and our overall temperature increases. Less heat is able to escape. Where do greenhouse gases come from? Well, 28% of them, the biggest slice of the pie, come from transportation. Now, this does include personal cars, but it also includes buses, trains, trucks, airplanes, cargo shipment. Think about all those massive shipping tankers around the world, commerce, all of the things about getting stuff to where it needs to go. So our personal cars are a part of it. We do need to rely less on fossil fuels for gasoline, but it's not the only part. like a major part of it is large shipments, large shipping containers and airplanes. That's everything going on the highway back and forth. Our next large chunk of the pie is electric power. Electric power is producing about a quarter of greenhouse gases. Then we have industry. Industry is manufacturing, producing all the things that we make. That is industry. We have commercial and residential. That is 13% of our pie. And then 10% of our pie is agriculture, our agricultural practices. Our estimate for 2021, which is like a nice number for us to work with, was 6,340 million metric tons of carbon dioxide. Where does this data come from? I got this from the EPA. I also have several pages at the end of this PowerPoint that have citations, so you can go through this data yourself. I'm trying to be really clear about where I get the data from so that you can explore it as you want. What are greenhouse gases? There's a lot of them. Carbon dioxide is the major one. So 79.4% of our most common greenhouse gases are carbon dioxide. And this is also from the EPA. Carbon dioxide, it is emitted during burning fossil fuels, which means burning gas and petroleum and oil, things that have to be drilled up from inside the earth. It also comes from cellular respiration. So I'm producing carbon dioxide right now. Decomposition produces carbon dioxide. Every living thing produces carbon dioxide. Carbon dioxide as a molecule is not evil, it's not bad, it's just a molecule. We've just started releasing a lot more of it by burning fossil fuels. We also release carbon dioxide with certain chemical reactions, such as cement. Making cement releases a lot of CO2, so that's problematic. And you can get carbon dioxide back out of the atmosphere when it's pulled into plants during photosynthesis. So that's cool. Plants are always the best. Our next slice of the pie is CH4. That's methane. That's going to be 11.5% of our most common greenhouse gases. Methane is emitted via burning coal and natural transport and oil. It's also emitted during livestock and agricultural practices and via decay in landfills. That livestock is a big one. So cows are a huge producer of methane, and methane is more powerful than CO2 as a heat trapping gas. So it's a more powerful greenhouse gas. One of the best things that an individual can do to limit the number of greenhouse gases emitted is eat less beef. Beef production, especially when it's large-scale beef production, produces a huge amount of methane. Our next slice of the pie is nitrous oxide. This is used in agriculture. I say used. This is emitted via agriculture, land use, industrial activities, burning fossil fuel, and in wastewater treatment, which I find very interesting. That's 6.2% of our most common greenhouse gases. And then we get into our small slice, our 3%. This is fluorinated gases. Go ahead and say those words to yourself. They're pretty fun. All of them are emitted from household, commercial, and industrial processes. And we are trying to count those and regulate those, but they are blanket statement put it together in fluorinated gases. So let's look at some data. Here we have the relationship between temperature on the planet Earth and carbon dioxide. Now note we have date years before present. So this is us right now at 0. And then we go back 200,000 years, 400,000 years, 800,000 years. You might be asking, how do I know what the temperature was or the carbon dioxide was 800,000 years ago? And the answer is ice cores. So if we drill down into the ice, we can access ice from that age, from 800,000 years ago. And ice has gases trapped in it. So there's little pieces of air in the ice, and we can measure the carbon dioxide in the air from 800,000 years ago. We have lots of other indicators of temperature. We also get that from ice core data. And so we get these cool maps where we have Arctic temperature at 0. then 5 degrees, -5 degrees, -10 degrees, and we see a flux in the Arctic temperature. And that flux is very well mirrored by the amount of carbon dioxide parts per million in the atmosphere in those little gas bubbles trapped in the ice. So these two graphs, if we were to lay them on top of each other, they're not exact. It's not like a perfect relationship, but it is a very clear mirroring relationship. The amount of carbon dioxide does affect the temperature on Earth. Now, these are old data, right? Hundreds of thousands of years ago. Let's look at the new data. This is our new data. We've got 0, us here, are 800,000 years ago. This is the graph I just showed you in purple. In that period of time, from 0 to 800,000 years, the previous highest amount of carbon dioxide was 300 parts per million. In 0, we now have our current day number, 2024, and it is at 422.8 parts per million. So there's a notable increase in the most recent data. How do we know? One of the ways that we know is using the Mauna Loa Observatory in Hawaii, and it is actually pulling carbon dioxide data from the air. It takes its measurements hourly and daily, and this is for our current period. So this is going to be April and May, and here we see daily and hourly averages showing this nice little bump. Mauna Loa started working in 1958, and we have these continual lines of parts per million carbon dioxide, how it has increased in the last 60 years. I have a video for you, which I think is really fascinating. It's the history of atmospheric carbon dioxide 800,000 years ago to January 2016. In this video, there's a lot of things going on, so I want to show it to you real quick. Okay, you're now looking at my browser. I have the video up that you will watch yourself later. I'm going to go ahead and play it. We have degrees from the equator, and then we have equator going up the center, and here is our parts per million of carbon dioxide. So we have every day right here. We're going to note when it changes. We have a blue and a red dot. Those are differences in latitude from the equator. So we're going to be watching this, pausing it, restarting it. Over on the right side, we have the date. We have a month calendar. So we're going to watch this. There we have 1 year gone, another year gone, another year gone. And as those years move on, this is going to be atmospheric carbon dioxide from the Mauna Loa Observatory and from the South Pole. We can see these track over time, keeping track of our dates. And then we have more people that are measuring carbon dioxide, and these are going to be local signals and background conditions. Those are going to pop up around the globe, so you can see where it's being tracked and how it's being counted. As we go through, we're going to note sustainable changes, not sustainable, important, significant changes here, and that will go on as we measure our carbon dioxide. Check out how frantic the local measurements are getting. Look at how many more are increasing on this map. So I'm not going to ruin the dramatic experience for you, but I want to work through what we're seeing. So we have parts per million on the left, parts per million on the right. That's carbon dioxide. This is the years, so we can track that with this map. And this is the equator, and these are our latitudes. So this is our South Pole, and this is Mauna Loa Observatory. Already, we have seen from 1979, look at how that's changed. So the rest of the video is absolutely fascinating. I'm going to go back to our lecture. If you noticed in that little graph, there's always variation in each year. What could explain the yearly fluctuations of this red line right here? Go ahead and ask yourself that question. Maybe pause it if you'd like a little more time to contemplate. And the answer is photosynthesis. So those fluctuations are going to relate to when we have summer growth, spring growth happening in the northern hemisphere. The northern hemisphere just contains more land, and so there's more plants doing photosynthesis in the northern hemisphere in August than there are in the southern hemisphere in December. And so when we have these decreases in carbon dioxide, that's because the plants are sucking it out of the atmosphere to make sugar. We know that they take that carbon dioxide and fix it into glucose. And so they're making a notable change in the carbon dioxide levels just by doing photosynthesis. So replanting and keeping our forested areas intact is something that we can be doing to decrease global CO2 levels, but it's not enough to keep up with the amount that we're pumping into the atmosphere. I've got a practice question for you. Carbon atoms get into leaves via the process of photosynthesis and exit the leaves via cellular respiration, which is the correct equation representing cellular respiration. So I'm pulling back some info from our first term. And the answer is going to be D. We're taking our carbon dioxide, or sorry, we are releasing carbon dioxide when we break up our photosynthetic product with oxygen. We also release water and energy. What's going to happen in the future with climate change? Well, we don't know, but we can make predictions. So here we have a graph. It's projected annual global carbon emissions. We have a high scenario, a mid scenario, a low scenario, even lower, and then what we know so far is in the black line. This is annual carbon emissions, and this is our years. Currently, we're right here. This is what we know so far. Now, I have the figure caption for you so you can read what RCP means, and I have the author of these diagrams so that you can know who made them. If we continue at a higher scenario, we're going to have an annual global carbon emissions of close to 30. And if we do medium, it's cut in about half. So that is a big difference. That's pretty exciting. These two lower, it even decreases to what it is right now by the year 2100. So we are not like in a point where we can't fix things. We absolutely have projections where things can get better than they are right now. What does that mean for global temperatures? Here are projected global temperatures based on our high, mid, and low RCPs. If we continue with the high idea, we think that the global temperature change will get to about 8 degrees. This wide band is fluctuation within air margin. So it could be 8 degrees, but it also could be like 5, or it could be over 10. So we have some unknowns about how that's going to happen. That's why these are large bands, but our expectation is about 8. If we do mid, it'll be about 4 degrees. And if we do low, it'll be about 2 degrees. And this is by the year 2101. So we don't know which one we're going to do, but we do know that something is going to happen. Like there's going to be a future. And in that future, there will be levels of carbon dioxide and there will be temperature changes. We now get to decide which of those we want to be our outcome. And I think that's really inspiring and really exciting, but we've got to start talking about it. And so the last thing I have for you in our Intro to Climate Change lecture, this is Katharine Hayhoe. Please note who was the author of these two projections, Katharine Hayhoe. So she is a climate scientist, and she's going to talk about what's the best thing, the most important thing we can do for climate change, and it's talk about it. Absolutely inspirational. I'm excited for you to listen to this. Email me anytime with questions, and we will talk soon. In your PowerPoint, you have several pages of PowerPoint with citations for you to check out. I'm not going to go through them because that's kind of boring, but email me anytime and we'll chat soon. Bye.